So let's look at Python being utilized to solve puzzles like this one. We've got to get this robot to this point here. The first thing is that you're just given move. If I play it, unlike Turtle, this is a little bit slow, so bear with me. It just moves once. So if I were to put move in a loop, so let's say for X in range, and say I wanted to move 3 times and place this by using the tab button inside, my robot would move 3 times and then smash its little face into the wall. So what we need instead is we need to utilize some basic concepts really. We need it to understand when it gets to the wall to stop being so suspicious and walking into the center of it. What we're going to do is we're going to use the conditions. We can see in the conditions you've got at goal object here, front right is clear, wall in front. Let's do front is clear, because if the front is clear, then we do want it to move. That's decent. And we also would like a situation where if it is not, if I believe the phrase they use here is wall in front, then we would like it to turn left, which we have as a concept. Reeborg's keyboard says commands, let's turn left. So I can put that in, and there we are. So if the wall is in front, it's going to turn left. If the front is clear, it will move. Now let's use a while. So while, I want it to do that until it's got to at goal. So we want it not, whilst not in the goal, I would like it to do these things. If the wall is in front, it's turn left. If front is clear, we'll move. So you can see straight away it turns left because there's a wall in front, and it's just going to keep going into the sky, and bam, it's just a lunatic flying around. So we now need a situation where if we need it to be able to read this concept of if there is something here that means it's about to fly off into the sky, we want it to turn right. So that kind of does exist. That's called, if you can see in Reeborg's keyboard, it gives you one of the conditions, wall on right. So we can say if wall on right, that's an interesting one, wall on right. If wall on right, then we would prefer for it to turn right. But if I run this, and any of you that understand Reeborg's world, there is no such thing as turn right. So we're going to need to do that. So I'm going to say for X in range, use 3 times, and you're going to turn left. And this is going to be the equivalent of, so we'll define it as, this will be the equivalent of turning right. Like so. And then I can put all of this inside that. And now when I ask to turn right here, it should do some stuff. So what have we got? So whilst it's not at goal, if the wall is on the right, it will turn right. And you see, the problem now is it's just spinning around like it's just a lunatic. So what we've got to do is we've got to get some things sorted. There's a situation where you have the wall on the right and the wall in front. So what we're going to do is we're going to mix these things up. So we're going to say if wall is on right, and then we're going to say inside that, if the wall is in front, then that is when we want it to turn left. So what that really means is if the wall is on the right, so you can see here the wall is on the right, and the wall is on front, you can see the wall is on front, then we want it to turn left. But there's another thing we need. Let's use the phrase else, or otherwise, we want you to move. Let's just get rid of that for now and see if it likes that behavior. So you can see it's now doing its thing here. So there we go. So you can see when there was a situation if the wall is in front, turn left. When the wall was not in front, so else, it moved. If wall on right, and just to prove what else is, I could also write this as if. Let's use the phrase wall in front and use not. This will also work, but else is the equivalent of that. So there you go. If wall on right and wall is in front, turn left. If not, move. So there we go. Okay, now what else do we need? well, there's a situation where if the wall is on the right, well, what about if there isn't? So another way you can put this is you can put this as else. Else, let's say we want it to turn right, right? We want it to turn right. So we're at this point here. There's no wall on the right of it. Else, turn right, move, turn right, and then move again. Turn right, move, turn right. Oops, root, turn right, and then move one more time, like so. And let's see now what happens if I run that. So it gets to that point where there is no wall on the right, and it turns right, and it turns right again, and then it moves, and then it's got the wall in front and the wall to the left, so it starts following the pattern. And this will probably carry on smoothly to the end. We'll see. So let's just have a quick conversation about this in terms of the theory. So that is to say, let's just get to grips with this concept. While not at the goal. So that pretty much just means that while not at the goal means when it is not here. When it is not there. That's while not at the goal. If wall on right. So you'll find that in this situation the wall is not on the right, but the wall is on the right in the beginning. So if wall on right includes this beginning bit here, right at the beginning, where the actual first thing that happens to this guy is that the wall is on his right. That's the first thing that this individual goes through. The wall is on the right. If the wall is in front, so that means in this situation where the wall is right in front of him, that's there. If the wall is in front, turn left. And we want that. We want him to go from here and instead to turn left. So that makes sense. If not wall in front, move. So that's that beginning bit. If the wall is on the right and there is not a wall in front, because remember this is second, this is the first thing it considers, one. Make that a little bit larger so you can see what I'm talking about. That's the first thing it considers. This is the second thing it considers. So it's like one, if the wall is on the right, so that's this beginning bit here. Then if not, if the wall is not in front of you, move. And that's why, for example, the first thing it does is it travels down here until it finally gets a wall in front. Next situation is, I said else, and else literally just means if the wall is not on the right, because it's else. And I could change that in the code just to prove that that's the correct situation. So rather than saying else, I could say if not wall on right. It would do the exact same thing, because else is the same as the not version of wall on right, or the not version of whatever your if is. And then so what does that mean? It means otherwise, if not wall on right, so pretty much these situations up here, this is when you have if not wall on right. That's that one, when he's at that peak point. Then we want him to turn right, move, so he'll turn right, he'll move here, and then he will move down like so. And so that is the pattern to recognize. That's why this structure works. Let's double check with hurdle 4. So I'm on hurdle 3 at the moment. Let's take a look at hurdle 4. Now again, this should be pretty similar. I don't think there'll be any issues with this one either. If I run it, like I said at the very beginning, while not at the goal, if wall is on the right, you can see the wall is on the right of this guy. He's going to make two choices. If the wall is in front, he'll turn left. If not wall in front, he'll move. And don't forget that I could change this if not wall in front to a little bit neater. I could just call it else. Else. And it will just keep moving across here until finally the wall will be in front and it will turn left. Then if not wall on right, which is the equivalent of if wall on right, I could also write this as else as well if you wanted to. This is a choice. I could write this as else. Turn right, so at this peak point here, turn right, come down. And we can run this and it should be exactly the same for that. So that is how we do hurdle 3 and hurdle 4 with regards to the use of definitions while and if, else, or if not. Thank you. Thank you.